Okay, well, I think we'll get started. Thank you all very much for being on time. We've got most people connected. There's still probably a few that'll connect within the next 5 to 10 minutes, but that's fine. We'll start without them. I'm Virginia Lapierre. I'd like to welcome you all to our webinar today with Avient. Today we'll be going through the webinar about elevated recycled resins. We'll be having a live demonstration after the presentations. We have two presentations from Remy Vogue from Roctool, who is a business developer with Roctool, and also Calypso Bololi from Roctool, who's our materials engineer, and very happy to have Etienne Peroni from Avient speaking with us today as well. So without further ado, I'll pass first of all, I don't know if you can see everybody's faces to say hello. And we'll get started now. I'll leave it over to you, Remy.
Thank you, Virginia. So I will share my screen. Okay, so basically a quick presentation on Roctool. So we are present on the three territories, right? In the US, in France, in Europe, sorry, and in Asia. With in Europe and Asia, we've got an independent engineering center within Roctool, and we also have platforms where we can demonstrate the technology with presses equipped with Roctool. So we are basically present in all the industries, right? All of them, of course, use more or less the sustainable materials, but each of them use a different application of Roctool, right? Automotive may use more aesthetics aspects of Roctool. Medical will more use all the stress reduction capabilities of Roctool or dimensional stability, right? Electronics may more go towards lightweighting applications. A few numbers about Roctool. So basically two things. Number one, it is a patented technology, right? There is 190 patents who's been registered by Mr. José Feigenblum, based in Asia. And number two things is it is not a new technology, it is an innovative technology, but we've done more than 45 million parts in about 30 countries for about 100 clients, right? So it is not new. So that's about the company in general. Now make a small focus on how does the technology works. So basically on the left side, you've got a conventional mold, and on the right side, you've got a Roctool mold. In a conventional mold, you will have basically a hot resin, which will arrive on a cold molding surface. Of course, what's going to be created is a frozen layer, and this frozen layer is going to be the source for some of the issue that you may face in injection thermoplastics, right? Some of them are aesthetics, right? You're talking about you're talking about weld line, stink marks, fiber visible at your face. And the second issue that you may face is more mechanical, right? Basically, this flow of this vein of resin that's going to flow through the mold is going to be somehow accelerated, and therefore you're going to have an alignment of the polymer chain in the direction of the flow, which will create anisotropy, right? Those issues we tend to solve most of them in Roctool by basically not having this frozen layer. Therefore, you will eliminate the weld lines. You will have a resin-rich surface, which will enable not to have visible fiber at your face. And you will have time in the process that we're going to see later to realign and to relax the polymer chain in order to decrease the anisotropy and therefore the molded in stress, right? So this is how it works. If you take, for instance, a PC, you go from 80 to 180 degrees. Let me take my pointer. This is time and this is temperature, right? So in conventional, you'll have a stable temperature, more or less, in the molding surface, whereas in Roctool, you're going to have a luxury to change your temperature dynamically, right? So you're going to go above this glass transition temperature, and then you're going to do what you have to do. You're going to inject your part, you're going to compact it. And as I said before, if you give the time for the polymer chain to realign, you will decrease the anisotropy, and that's what we're doing here. You do what you have to do, and then as soon as everything is done, then you go and cool down. So what does it look like inside the mold, right? So the important point here, the very important point, is you have two different channels for heating and for cooling, right? So you have this luxury again to have different heating and cooling profiles. So basically you will drill or mill inside your mold holes to pass the inductors, right? I'm not going into the detail of the physics of the induction, we don't have time, but basically you're gonna have holes from 4 to 10 millimeters away from the molding surface, and behind that you will have the water channels that will flow continuously. You never stop flowing the water channels. So what do we sell, right? We basically provide a service, right? An engineering service that will basically define exactly where those holes or those grooves need to be positioned, right? And that's a fine art. And then number two, we provide equipment. Whatever will be required to turn a standard mold in a Roctool mold, right? You're talking about inductors, connection boxes, wires that can cope with very high voltage and currents that we're using for this technology. That's number one. And number two is the generator, right, which is the heart of the technology, and it's going to generate this very strong current every, let's say, 45 seconds, day and night. So basically, this is actually my last slide. It's just a quick introduction. Roctool is known mostly for aesthetics, right? We're talking about improvement of gloss, which is a big added value for the rest of the presentation that's going to be done by Etienne and Calypso and the demonstration. Removal of defaults, as I said at the beginning, with Weldline and Sigma, because you don't have this frozen layer, and then replication of very fine textures. This is what we're known for, but that's not everything, right? We also, and as I said at the beginning, in some of the industry, they don't really use this one, right? They more use the decrease of a scrap rate, which is because we're using electricity, and electricity is a very stable process. It's a very stable physics. We are used for flow improvement. If you have very long parts, very fine parts, you want to improve the flow. Roctool is used for stress reduction. As I said in the first slide, we reduce the anisotropy, and we can be used for cycle time reduction because we can use cold water to cool down the mold. And of course, dimensional stability, because at the end, our job is to control the mold surface temperature, and we are experts in that domain. So of course, if you do control the mold temperature, then you will control the dimensional stability of your part. And then the last domain of application of Roctool is the functional applications. Basically, is for instance, you take a hydrophobic texture. Without Roctool, you will not replicate it, and you will not have a function of this texture, right? Same thing with holographic textures. It can be very nice on the mold, but if it's not replicated on the part, then it's you will need Roctool. And then you get the lightweighting. The aim is reducing the material part on your the material part on your part, and of course the sustainable material, which is going to be covered by Etienne and Calypso in the rest of this presentation. Back to you, Virginia.
Thank you very much, Remy. We've just had a couple of questions, which I think we can probably answer fairly quickly before we move on to Etienne, and then the rest of the questions we will try to keep till the end. Remy, we have one question. Can we have conformal channels for heating?
Basically, there is different types of integration, right? It really depends on the geometry of the parts, right? The best thing to do is if we can do an NDA and share the 3D, then we can have a very precise answer on how we would integrate. Would it be just a drilling channel? Do we have to do a groove? So we can go into detail in answering that after.
Okay, and one more question. How much is the typical distance in millimeters between molding surface and the heating channels? Approximately.
It can go anywhere from 4 to 10. Here again, it depends on the projected surface of your part, which will define the amount of power you need to heat up this molding surface, which will define a diameter, which will define a space between the molding surface and the inductor.
Okay, thank you very much. There's another message, but I think Arnaud Kumar, the question about the energy usage on the sustainability scale, that will be coming up in Calypso's presentation. So we'll leave that for the moment. We'll go on to Etienne. Thank you very much.
Thank you, Virginia. Thank you very much, Remy, for this nice presentation. Can you see my screen?
Not yet.
Okay. Maybe you should see my screen.
Not yet.
Okay.
Well, while we're waiting on that, I'll just mention to everybody that's watching as well that you'll see on the right-hand side of your screen where you can ask questions in the chat and the different settings for where I put a poll. There'll be a few polls during the next hour. So that's great. Etienne, your screen is now shared. I'll leave you to it.
Thank you very much. So let's talk about the material chapter of this webinar. We will present you how density modified formulation can bring value to your developments. Related to the agenda, I will introduce Avient first. Then we will see how can plastics improve aesthetics. We will go through Avient solution regarding the Gravitech range, product range, electroplated material, and improved sustainability. Then I will detail a few applications used for these materials, and finally we have a conclusion. So first, we'd like to be seen as a complex material science problem solvers at Avient. We are 9,100 people worldwide. We are providing more than 35,000 solutions to the market and generating $4 billion in sales. We have donated 1.6 million to charitable organizations in 2019. And finally, we are operating with 105 facilities in more than 30 countries worldwide. Related to our value proposition, we are present in 3 different segments: color, additives and inks, engineering polymer formulation, and polymer distribution. On the color, additive and inks, we are providing solid and liquid colorants, performance additives, plastisols, and inks. We are also providing engineering formulation, advancing composites, TPEs, and urethanes. And finally, for the polymer distribution, we are a world-class supplier line card for a North American leader in plastic distribution. So related to how we can improve the sustainability while maintaining aesthetic. The main concern we have when it comes to improve sustainability is to guarantee acceptable aesthetic level. As a starting point, we can see on the market that ABS has been the dominant material for closure in the packaging industry. The market is moving towards more sustainable solution. Avient is developing more sustainable solution while maintaining excellent aesthetics, ideal for use in luxury packaging. Here, we just want to explain deeper how we can combine aesthetics and processing. So high density and cool fill make aluminium, zinc, iron, steel, and alloys the primary choice for the premium market, but their processing restriction limit their design capabilities. Injection molding and low cost of PP and ABS make them the primary choice for the mass market, but their aesthetic restriction limit their appeal to premium brands. We have developed a metal polymer composite that combine aesthetic and processing capabilities in order to provide this combination, and we have developed a Gravitech product range to provide this. So when it comes to electroplating, after a long testing campaign with an electroplating partner, we have been able to formulate different material that offer some of the best results for electroplating on the market. So on the screen, you can see the main characteristics were the quality aspects and the adhesion test. And for different material, we have been successful on both tests. Here we are talking about PP-based material. And we have performed some tests first on plaques. And currently we are making some tests on existing products to make sure that the result will be confirmed. So we have been able to launch on the market electroplatable polypropylene with different density levels for cosmetic and spirits closure application. So we are talking about density 1.9 and 2.5, and we are working in parallel to develop other density levels. When it comes to improving sustainability, so we are now focusing on a post-industrial recycled polypropylene, black polypropylene, and this solution provides a styrene-free solution, lower carbon footprint versus ABS. As you can see on the graph on the screen, on the left side of the screen, the CO2 footprint of the ABS compared to the footprint of polypropylene and high-density polypropylene is half lower on the polypropylene side. The polypropylene improved the chemical resistance versus ABS. We maintain prime polypropylene performance, and we have a lower rigidity than ABS, ideal for new designs. Here you can see what we have done with Roctool. We have worked on the custom formulation and also used the Roctool technology. On the left side, you can see the result we had with the Roctool process. Without Roctool process, and on the right side you can see the result we have able to have with the Roctool process. So the advantage is that we have a quite similar ABS quality surface aesthetics, high material brightness, and lower mold pressure required, and good material flow characteristics. Here you have an overview of different applications. We'd like to allow you to visualize on which kind of application our Gravitech solution can be used. So depending on the density, depending on the cool touch, depending on different aspects. So on the left side, you can see mascara application where 1.2 density material can be used. Then you can see a lipstick application with 1.9 density can be used, and to also have the cool touch effect. Then we can have a perfume cap with a higher density, density 3, with the cold touch, ballast effect, and also the magnetic function. And finally, we can also use our material with higher density, density 4, for a house wheel, having the cold touch, the ballast effect, and also the magnetic function. Just to summarize, by combining the Roctool technology and Avient material, we can have a great aesthetic without secondary operations. We can improve sustainability by making less CO2 consuming choices, replacing ABS by polypropylene, using recycled material, removing secondary operations, improve surface aesthetics, remove need and cost for secondary processes like painting, assembly, metal ballast sourcing, and simplify the design and reduce the number of components used. In case of question, I will be more than happy to answer later on. You can also send me or contact me by email, and I will be more than happy to answer. Thank you for your attention.
Thank you very much, Etienne, for sharing the slides and introducing Avient to everybody that's attending us at the moment. Calypso, if you're ready, you can take over the screen, and we'll and then following Calypso's presentation, we'll be going directly to the live demonstration. Thank you.
Thank you. So just confirm me that you will see my screen, please.
We see it. It's all good.
Great. Thanks. So thank you, Etienne, for this presentation. It's a very good introduction to what I am going to present to you. So the idea is to present you how Roctool can combine sustainability and high quality product. So to do that, we have a key factor to elevate sustainability using Roctool technology. First factor will be using recycled materials and the capability to obtain a premium look on your molding part. So you have some examples here of recycled material molded with Roctool technology. Here it's an example of 100% of PCR ABS PC, and as you can see, it's a very good quality surface without any defect and high gloss surface and replication. Then the second factor could be to use organic or waste material. That is the second pictures. This is reclaimed clothing, and we are able to mold it by compression, a very good part using reclaimed clothing. So it's a second type of materials from reclaim that we can use and obtain a very good premium look. Another point, and really important, is the capability of elimination or reduction of secondary operation like paint or spray or varnish. And this is very important because due to the chemical product using for this kind of secondary operation, if we are able to reduce or eliminate, we have a good reduction of CO2 emission, for example, and that is a key point using Roctool. As we are able to obtain a premium look, we are able to reduce or eliminate this kind of secondary operation. Last point, but not the least, is cycle time and energy saving. So it's everything is combining, because using recycled material or eliminate secondary operation, you will of course reduce your complete cycle time and your energy consumption. So now let's go to some examples of what we are able to achieve with Roctool technology and recycled resins. First example, it's a PCR resin. So at the left, it's 100% recycled ABS. And as you can see, we have good surface aspects, elimination of the blush at the middle of the part, no defects, and ultra gloss on the part, good improvement compared to conventional parts, and perfect replication of the surface, in particular around the eyes with the holographic effect. On the right, it's a PP PCR, 100% also, and in this case, we can see a perfect surface aspect, no wet lines here, and perfect, replication of this structure using Roctool technology. Another example is ABS-PC and is molding with our sphere tool. So it's a very complex shape with many holes. And as you can see in conventional, you have many wet lines and some defects from the materials. And with Roctool, you can see here complete elimination of these wet lines and no defects, black intensity, and high gloss surface. So it's important to understand that we can do also on a complex shape, integrate our technology to achieve a premium look. Other materials, and it's a PIR materials, it's a PP from Avient. So it's where starts the story with Avient. They came from us with this PP with the mineral fibers and mineral fillers. And the idea was to see how much we can improve the part. And here you have just the results, as Etienne also presents, but also in terms of replication and soft touch effect. Other kind of materials is biosource resins. So it exists now more and more, and that is very interesting. And the idea of Roctool is to evaluate how much we can improve and what we can do with this kind of resin. So on the left is 45% of biosource materials. And as you can see, we have a really good replication of the texture, high gloss surface, and very interesting structure. So that means we are able to mold this kind of materials. And on the right, it's 100% biodegradable materials. And with this resin, you can see normally in conventional some kind of wood fibers, I will say. And with Roctool, we are able to have perfect homogeneity, very good quality surface, and that is very interesting for packaging project, for example. And to finish my examples, this is a PP with wood fibers. So the idea, is to use wood fibers to achieve some kind of natural part. And in this case, again, normally you will have some, heterogeneous fiber distribution in conventional, and with Roctool we can achieve a good surface aspect, good distribution, and with elimination of wet line and surface defects like stink marks. Okay, so we see some example of what we can do and how much we can improve the quality aspect of the part. Now I am going to explain you how we can also be sustainable with Roctool. The second point is the improvement of the flow length using Roctool technology, and that can mean you are able to reduce the thickness of some parts and so the amounts of your materials. So here you have some example of PCR and PIR resin that we have evaluated with our spiral mold, and in order to show you how much we can improve the flow and maybe the capability to reduce some thickness of parts. So the trials have been done with a spiral mold at 1 millimeter of thickness. And as you can see, for ABS to PP, we have a huge improvement of the thickness. And that is very interesting when you have a project and you are looking for thickness reduction. That could be done and using recycled resin. So it's a good combination for some projects. Another point, very important, is the CO2 emission, as I said before. And here we have done a study very interesting with our box mold, 2 cavities. And the idea is to evaluate the CO2 emission in conventional process versus Roctool technology. For this study, we take in account 1 million part production. You will see a comparison between standard or virgin ABS to PCR ABS. The study has been based in Europe, and you will see also the impact of the decoration, paint line, varnish line. We take in account the Roctool equipment, the transport, packaging, and of course the scraps. So first case is ABS in conventional, 30 degrees with decoration in order to obtain very good surface aspect. So in this case, you will have in blue the resin, in red the injection process, and in green the decoration. So to do 1 million parts with this mold, you will use 492 tons of CO2. So let's now compare with Roctool, same ABS, with only varnish, so no paint in this case. So you can see a reduction of the resin because we will reduce the scrap induced by the decoration process as we reduce the number of steps of decoration. We reduce a little bit the injection process due to the less part molded, but we add the Roctool process, of course, and we keep a very small amount of CO2 emission from decoration. So in this case, we reduce the CO2 emission to reduction to 33%. So that is already very interesting. Now let's go in another step. It's completely elimination of decoration. In this case, reduce again the amount of the material because we don't have any scrap from the decoration. Same injection process, and we reduce a little bit the Roctool process due to the reductions on the molding part. In this case, the reduction will be 41% CO2 emission. So it's a new step of the reduction. And last point, and not the least, is a comparison with PCR ABS with Roctool. And in this case, you can already see a huge difference. Why? Because as we recycle the material, we reduce, of course, the CO2 emission from the production because we have no production, it's just recyclability. Then we keep the same amount of injection process and Roctool, of course. So in this case, the reduction is very huge. It's 80% of CO2 emission of reduction. So it's very interesting to see what you can do. You can go to completely sustainable project with PCR ABS with Roctool, but there is on between some steps that you can evaluate and for your next project. So now I am going to our demo center to show you the demo live. So see you in a few minutes, and I will let Etienne to present you the demo live with the materials.
Thank you very much, Calypso. I might just, before you start, Etienne, we might just go over a couple quick questions. Amanda, she asked if why it would be good to step away from ABS and move closer towards Avient's solutions. If you wouldn't mind replying briefly to that, Etienne.
Yeah, sure. The market trend is to step for to move forward from ABS due to the fact that the market is looking for steering-free solution, and that's why the market is moving to, let's say, polypropylene solution or different solution. And the other thing is that ABS has a higher, as you can see on the presentation, ABS has a higher carbon footprint compared to polypropylene, for example. This is the two main reasons we see why the market is moving from ABS to other more sustainable and solutions, also for regulatory reason.
Okay, Etienne, if you wouldn't mind going on to the next slide, please.
Sure. Yeah.
Thank you.
Can you switch the slide?
Yes, the other two slides that you're going to present while Calypso goes to the live demo.
Okay, so I need to share my screen just a few seconds.
Perfect,
Okay.
thank you.
You're welcome. So I will detail more the material that will be used during the live demo. We are talking about post-industrial recycled polypropylene. It's a density 1.9 material, mainly used for metal replacement. So for the ballast effect, you have also the cool touch with this material, and can be also used for assembly and 2K operations removal. To simplify the design and assembly of devices like lipstick. And this material is mainly used for cosmetic and spirit applications. And when it comes to the mold characteristic for the live demo, Roctool will use a 2-cavity mold and with one heating side. The mobile side will be heated. And as I said, we will use the polypropylene resin from Avient with the Gravitech material. But I don't know if Calypso is ready.
She's almost in place. You'll see her come onto the screen any second.
Okay. I don't know if we have some additional question in just in between.
I think we might get on with the live demo and then we'll cover all the other questions after the live demonstration.
Okay, perfect.
Thank you.
You're welcome.
Okay, well, welcome to our demo center. So it's our injection machine. This is David. He will perform the trials for today. And the idea is to use the material from Avient that Etienne presented to you with and without Roctool technology in order to compare the results. So first, we are going to show you the mold. So as you can see, this is a cavity with this fine texture, really nice, with some holographic effect. I don't know if you see well, but anyway, you will see on the part. And the idea is to mold now with and without Roctool. So David will start without Roctool technology. Okay, so for this step, we have fixed our thermoregulator to 30 degrees on fixed side and mobile side. And we will have a look on our cycle time just here. So you will see the evolution of the cycle time for this molding. So we will wait now the demolding of the part. The idea is then to compare the cycle time with and without Roctool also. Okay, it's done. So around 53 seconds. And now we have the demolding. So let's see the part. Okay, so as you can see, the part is really bad. You can see this milky effect, no eyeglass surface, and the texture is very difficult to see. And we don't see any hologram effect around the eyes. So it's not a good part, let's say. And now we will turn on Roctool to compare the results. So let's go, David, with Roctool technology. So we can see on the controller the temperature increase, and we will achieve 120 for the injection. So we have just inject now, and we are now cooling, waiting 50 degrees for the demolding. To achieve 120, we have fixed our generator to 15 kilowatt. The thermoregulator has been fixed again at 30 degrees. And we can again check the cycle time to show you that we achieve exactly, or let's say a similar cycle time with and without Roctool technology. We are quicker. 50 seconds for this cycle. And now we can check the part. Okay. So clearly, I think you clearly see the difference. The eye gloss your face, the also holographic effect around the eyes are now really clear. So we can just put the two parts together, but the difference is very huge. So let's now go back to the presentation to show you the gloss and color measurements.
Thank you very much, Calypso, for that wonderful live demonstration. We'll just take off the two videos. Okay, so we'll go on to the results. And I'll let Calypso continue speaking.
Yes, thank you, Virginia. So as you can see, is the same part that I just showed you during the demonstration. We have measured the gloss using our gloss meter, and the results are very different. So in this case, we have 9 gloss units in conventional versus 93 gloss units with Roctool. That it's obvious, elimination of milky effect. Oh, sorry, I try to just show you. But it was obvious, yes, the milky effect and the low gloss surface, and the comparison of the replication also is huge. So second part is the measurement of the color. So that is very interesting. We use our spectrocolorimeter to measure the LAB value. The idea is to see only the L data because it's about the black and white color. And as you can see, the L value with Roctool is lower than the one in conventional. What that means? That means that we are deeper in terms of black intensity with Roctool. So that it's very interesting, like when you are looking for a deep black, and that can be achieved using Roctool technology. So I think we present everything about this demonstration and those results. So now we are going to do the question and answer. So don't hesitate to write on the chat for some questions.
Okay, once again, thank you, Calypso. You'll see on your screen there's the various email addresses. Please don't hesitate to reach out to us if you require any further information. There's been several questions during the last 45 minutes as to whether we will share the presentation. I can send you all a link to that after this presentation. Now, to go over these questions, let's see. We've answered those here. In terms of energy usage sustainable scale, I think Anu Kumar, I think that question was answered by Calypso during the presentation. If not, please reach out to her directly for that. There's a question about how does Roctool impact the crystallization of the material. Calypso will actually contact you directly, Nazim, regarding that, because she'll need to show you a schema, and it's a little bit more complicated and will take a little bit longer than the time that we have currently. Amanda, what are the advantages of Roctool over heat and cool competitors? Remy, perhaps you can answer that. Don't forget to put on your...
Yeah, sure. Can you hear me?
Yes.
Yeah, so basically, we do have, I mean, our real competitor, to be honest, is a conventional molding, right? But there are other ways of heating up a mold. Some of them are, let's say, slower. I mean, we're definitely faster. It's not pretentious to say that. There is no faster way to heat up a mold, the molding surface, than using induction. That's what, at the very beginning, at the birth of Roctool, we moved towards induction, right? That's number one, the speed. Number two is the precision, right? Take lights in this room, switch it on and off 1 million times. It will put exactly the same light. It will not drop, it will not fluctuate, it will be exactly the same because it is electricity. Number three, we have a dry technology, right? So, same again, in this room, you will never change the wires, right? Because it's electricity, you don't need to change it. If it would be fluid, right, you will need to change it yearly, every 10 years, I don't know. But if you have pressure, if you have water, you will have corrosion, right? We don't have these kind of issues. So this is the three main things why our real competitor is the conventional molding. If our clients can solve their issues on weld lines without Roctool, then there is no, I mean, weld lines or other things, then it's the real competition for you. Any other question?
Okay, there's another one that has come in saying, did you apply any recycled materials for headlamp housings? Again, Remy, I think I'll let you answer that one because there's a lot we can talk about, but we do need to try and keep within the time frame. We've got another 10 minutes still to go. Off you go.
Sure, headlamp technologies, not to my mind. But I will need to revert to some people that may have been in Roctool before I was, and then maybe they have examples that I don't have. Virginia, I will take the email and I'll revert.
Absolutely. Okay, there's a question here for Etienne. What is the main environmental problem with styrene?
The thing is that there are a boat. I thought it was on the east side of the world. There are an accident with a boat that contained liquid styrene, and it has been very hurtful for the environment. And there are some, push related to this environment accident related to styrene, who drive to some big players to change their mind related to styrene's solution. So we see with a cosmetic player, but not also only for the packaging side, more globally, a push to try to change and to use more solutions that are styrene free.
Thank you very much. Next question. When running the non-Roctool part, what other settings of speed, holding and cooling was used? Maybe Calypso could reply.
Yeah, in fact, of course, we will modify some parameters for the injection molding without Roctool compared to with Roctool, because with Roctool, we are able to inject with a lower speed because we will not have the freezing of the material at the contact of the mold compared to conventional. So that will be the main difference. Also for the packing, normally in conventional you will have a huge packing because you freeze, so you need to have a lot of pressure compared to Roctool, or you can have a longer packing because you are still, in the melting phase, let's say. So this is the main difference between both, and that will induce something very interesting is the reduction of the internal stress. So it's also a parameter, important parameter for some application, because you improve your mechanical performance with Roctool compared to without, because you reduce this internal stress on your part.
Thank you very much. The next question, again for you, Calypso. In the trial, in terms of color, what were you comparing to?
Yeah, so we are measuring the LAB value. So the comparison will be, if we can we go back to my previous slide? Yeah, no, just this one. So yeah, if you see on the screen at the right this sphere, so you can see how it's going. So the L is from the black to the white. Okay, the value A is from the green to the red, and the value B will be from the blue to the yellow. So the spectrocalorimeter will measure these 4 values and will give you an idea of where is your positioning for each value with and without Roctool. And so in this case, we were looking in particular about the L, because we have a black part, and the L is the measurement of that. And as I say, we have a reduction of the L. That means we are near to the 0 value, which means black intensity when you are in the night. And that means we have an improvement of black intensity using Roctool technology. But that was also obvious when you were looking on the part due to the milky effect.
Thank you, Calypso. Remy, who is using the recycling machines in India for automobile application?
Well, this is equivalent to releasing my list of clients, which I can't do, unfortunately. No, we don't drop names, especially on a webinar. I'm sorry.
Okay, that's fine. Thank you. Let's see, who else have we got here? There's lots of questions coming in. Are there any examples of improving the weld line strength using this technology?
So yes, and I will let Calypso after comment on that. We actually have a dedicated mold to demonstrate that. Calypso, do you want to say a word on this? Well,
sorry,
so
I was in mute, sorry. Yeah, we have a specific dog bone mold to evaluate the mechanical performance on the weld line. So if you are interested on that, don't hesitate to contact Remy. Like that, we can discuss about evaluation of your materials with our specific mold, as we are able to inject in 1 or 2 points in order to do the dog bones following some standard. So yeah, please come back to us and we can discuss in detail about that.
And Calypso did characterize many material with this dog bone mold for clients. So this is a business as usual for us. Next, Virginia.
Amanda is asking, does Roctool have operations in Asia, especially China? We certainly do. Remy, you can speak a little more about that if you like.
Well, actually, just to make it very short, yes, we have very extensive operation in Asia, and just in a word, our chief technical officer, the one that basically created the technology, is called José Feigenblum, is a French person. He is based in India and he is running the business there. So it's to prove
you mean
how
China?
In China,
not India.
Yes.
Yeah.
Sorry, India. No, China. I'm sorry.
It's okay. Thank you. A question for Etienne. Is there any difference of quality between different lots of materials?
We are talking here about post-industrial recycled polypropylene. So compared to the post-consumer recycled material, with the PIR, we have a more consistent and more repeatability compared to the PCR, because we can establish a closed loop related to this. So we are using industrial scraps or screws or defective parts from identified source that we use to make the recycled polypropylene or to make the final formulation. So we have higher traceability here, and we are able to have a more consistent from batch to batch.
Thank you very much.
I hope I have answered the question.
Sorry?
I hope I have answered the question. Feel free to let me know if this is not enough clear.
Okay, there's more questions coming in as we speak. Remy, just a quick question for you. How many projects have we completed so far, and who are our major customers? Well, our major customers, unfortunately, we can't really tell them due to confidential agreements. However, I'll let you, Remy, continue on with that.
Well, basically, as I said in my early slides, we are present in most of industry, right? Of course, I cannot give the names, but in the automotive industry, we work on basically every interior and exterior parts, right? On different challenges to resolve, would it be word lines, sink marks, gloss, whatever. We're present in a very large consumer brands in different sectors: electronic, sport, home appliances. So it's we cannot drop names, but we have about 100 clients. Next.
Okay, well, thank you very much. I think we'll leave it there now. We're almost at 10 o'clock. There's a couple of other questions that have come in. There's certain things that we will reply individually to you because they do take a little bit longer to reply rather than just a couple of quick minutes on a webinar. I hope very much that you've enjoyed this session today, and I'll just put on everybody's cameras to say goodbye. And
yes, thank you, everybody.
Please don't hesitate to reach out to us by email, and we will hopefully hear from you soon. And I will send you all the link to the presentation that was shown today. Thank you very much. Bye-bye.
Thank you.
Thank you.
Thank you. Bye-bye.